Harvard MIT Math Tournament 2021 Algebra and Number Theory Round Problem number 7. We want to solve this problem. I will tell you the necessary things that are important and useful for complex numbers, that is useful in math competitions, math Olympiad in America and other countries, and then we solve this problem. If you had any question about the solution of this problem or other problems, feel free to send message to my WhatsApp number in the description and comments. Also, you can use my playlist on top of the video. There are many problems of Harvard MIT math competitions and math tournament. And please subscribe and turn on notification and like the video to have next videos. Okay, let's start solve this problem. Suppose that x, y, and z are complex numbers of equal magnitude that satisfy x plus y plus z equals negative root 3 over 2 minus I root 5. And if x equals x1 plus I x2, y equals y1 plus I y2, and z equals z1 plus I z2. For real numbers, for real x1, x2, y1, y2, z1, and z2, then what is x1, x2 plus y1, y2 plus z1, z2 squared can be written. Then this term can be written as a over b for relatively prime positive integers a and b. Compute 100a plus b. Okay, so for solving this problem, the first idea we need is conjugate. So if x is a plus bi, we consider x conjugate a minus bi. And if we multiply x conjugate is what is a squared and minus abi plus abi, they will be cancelled. And here bi, negative bi, it will be negative bi squared. I squared is negative 1, so it will be a squared plus b squared. And also you can show x as, for example, its magnitude rei theta. If, for example, the length here is r and it is theta. And r equals what? Root a squared b squared. By Pythagoras theorem you can easily prove, because a, b, so one length is b, one length is a, one length b, so it is here it is this one and the others. We want to say x is x1 plus I x2, because we want x1, x2, you can say, okay, x squared is what? This x is not this x. So, for example, let me write this x. I just wanted to tell you these ideas. X is x1 plus x2, and someone maybe ask how we can understand we use this formula or this formula. It depends on the problem. So when you see a problem, new problem, check both of them, and after solving some problems you will understand which of them is more useful. Then if you raise both sides to the power of 2, it will be x1 squared minus x2 squared plus 2i x1 x2. So if you want to find x1, x2, it is imaginary part, it is real part. So imaginary part of x squared is 2x1, x2. Okay, so here, so x squared is a squared plus b squared, which is r squared. Now, let's consider from this part, x, y, z is this. So if you consider the magnitude of each side, the left side will be, suppose x, for example, it says they have equal magnitude, so x equals z equals r. All of them equals, for example, r here. So if you consider the norm, the left side will be r cubed, the right side will be what? Root this squared plus this will be 3 plus 5, root 8, and we can conclude r is root 2. So from this one we can understand r is root 2. Now let's consider this part. Now if you consider conjugate of each side, so here we said what? X conjugate is what? R squared. R is what here? R is root 2. So x conjugate, or let me tell you, we write what? X conjugate is what is 2, because it is r squared. So you can say x is 2 over x conjugate, and also x conjugate is 2 over x. And you can say if you consider conjugate of this, they are equal, and plus change to minus. So you can consider conjugate of each of them. X conjugate plus y conjugate plus z conjugate equals what? negative root 3 over 2 plus I root 5. X conjugate is what? 2 over x plus 2 over y plus 2 over z equals negative root 3 over 2 plus I root 5. So here we can conclude what? 2yz plus xz plus xy all over xyz equals negative root 3 over 2 plus I root 5. Now, let me tell you why we consider conjugate of that. Because do you agree? Look, in these problems, consider a little assumption, a little sentence. We said x1, x2 is what? Is imaginary part of x squared. So this part, you can say it is equal to 1/2, because x1, x2. Imaginary part of each of them, so you can say imaginary part of x1, x2, imaginary part of x squared by this, plus y squared plus z squared, and this part, let me erase this one. Okay, so it will be what? Imaginary 1/2 imaginary part of this squared. So I need to find x squared, y squared, z squared. I know x plus y plus z is what? So I can say x squared plus y squared plus z squared is x plus y plus z squared minus 2xy, 2xz, 2yz. Okay, so let me copy this part. Copy, and here I say what? I say, okay, I want to find this x squared plus y squared plus z squared. Because I want to find this, it is what? X plus y plus z squared minus 2. You should memorize this identity. 2xy plus xz plus yz. Now, here we want to replace x plus y plus z is what? Negative root 3 over 2 from here minus I root 5 squared minus 2xy, this one, it will be minus xyz times this. Xyz is what here? Root 3 plus I root 5. Root 3 plus I root 5. You cross multiply here, minus root 3 over 2 plus I root 5. So here it's x squared plus y squared plus z squared. We should calculate this, and then we need what? Imaginary part of that. So we need only find imaginary part of that and then divide by 2, then squared. So if we consider imaginary part, we don't need to calculate it completely. It will be what? 2 times this times this. It will be 2 times this. They will be cancelled. Root 3. It will be I root 15. And the next part, root 3 times this minus I root 15. And the next part, this times this, minus minus plus I root 15 over 2. Now, here we can see they will be cancelled like this. So imaginary part will be what? Root 15 over 2. We have also T2 here. So it will be root 15 over 4. And we have squared here, so it will be what? 15 over 16. So it is a over b, and they are relatively prime numbers. And the problem says what? 100a plus b. So 100a plus b will be what? 1500 plus 16. So the answer is 1516. Okay. So for having next videos, subscribe my YouTube channel, turn on notification, like the video, and also if you had any question about these problems or other problems, feel free to send message to my WhatsApp number in the description and comments. And also you can use my videos about Harvard, MIT math tournaments, hard problems and also easy problems, and you can use the videos and playlists. Thanks for seeing this video.